Hello and welcome back to yet another development log of Glaucus Linux, where we still didn't or haven't figured out how to solve that toolchain bootstrapping issue. Um, this is the third part, which is kind of ridiculous for an issue of this scale, but I think I have an idea of what was going on. See, I've been reading the log files in a more detailed fashion, and I noticed something interesting. Now, if you can recall in the previous development log, I was surprised to see some of these flags used for lib standard C++. I was like, why is the standard build process for lib standard C++ and the rest using these optimization flags? And I was surprised. One moment. Yeah, so I was surprised to see um, like the other toolchain packages actually using these flags, these optimization flags, because it doesn't make any sense to optimize this early on. I was also surprised that it, so regardless, so something must have been wrong, something that allowed these optimization flags to be passed in toolchain. So I went to the package builder and I was reading or checking out this function. So let's check the symbols and we have a build package. So this build packages function, which defaults to the native stage. Um, this is where like environment flags, C build flags, and make flags and linker flags are applied. C flags are used in multiple places, like C++ flags also use C flags and linker flags for LTO to be more effective. C flags are appended as well. I think I had a check for the stage, like these flags shouldn't be applied like blindly to all stages. Sorry about that. So I probably reworked this without keeping that in mind. So it should definitely check. So this, if the stage is native, um, so I don't think I'm going to apply these optimizations to native only. Like my plan is to optimize across like stage 2. If stage 1 was the toolchain, then stage 2 is cross. Toolchain obviously shouldn't be optimized, but the earlier parts of the cross-compiled system doesn't hurt to optimize them to rule out any later misconfigurations and stuff. So it works as an early, test bed. It works also without optimizations. They're not that severe of optimizations or that aggressive. Well, I guess you can say that LTO might be somewhat aggressive, but yeah. Other than that, like the linker flags might be excessive, I know, but they're needed. So we can do something similar to this. So we can say if the stage was not equal to toolchain, and we can say that this is, and then we can grab this because I believe some packages still use this in toolchain. The others aren't used. And we can do it, put env and should be done. Okay. So this way, I think C flags, and the others won't be set in the environment variable for the toolchain environment. So we'll need to build. Let's do it directly this time. I should have checked binary utilities as well, the previous log files, just to confirm that these weren't applied, but we'll check them now. Okay, it should take about a minute. Let's see. So once the tool chain is working, is building fine and is actually capable of building stuff, it shouldn't take that much time now. We'll start working on the cross-compiled system. I'm expecting a lot more breakages. Like these were, the toolchain breakages are always like, uh, it's not that it's fragile, but it's like sensitive and can't go on modify a lot of things and expect it to run smoothly. But once it works like and is capable of rebuilding itself and the entire system, like that's when it um, you can say it's a bit stable. It becomes stable with time and with more testing. I also should probably like tone down the tool chain changes at this point. Like some distributions are still stuck with versions of packages like that are so old, like a couple of years, maybe more at this point, just for the sake of keeping the tool chain stable. And I doubt that any distribution is actually uh, continuously bootstrapping itself from stage one. Some distributions are, which is always a good exercise to do, but other self-hosting mainstream ones, like once they self-host, uh, apparently there is not that much of a point, which I disagree with, but it's the status quo, unfortunately. And I hope with the bootstrappable project and the efforts by some distributions like Geeks and others, like they're attempting a bootstrap from stage zero, which is from absolute nothingness, like the live bootstrap project, if I recall correctly. Let's see. This took longer than expected. Okay, took some time. Yes, it doesn't look like. Yep, it's not using the crazy optimizations that we had, which is relieving, at least for this part. So I'm going to pause until GCC finishes. And we're back. This took longer than I expected, much longer actually. I must have disabled or removed a lot of options from GCC's and libgcc, the static versions configuration for that to happen. Usually it takes around 15 minutes. 15 minutes, so to be precise, or 17 minutes or something, but it took around like 40 minutes. I hope it didn't do a 3-stage bootstrap for GCC, but we'll find out. So let's check the configuration file. So looks like, yeah, it's not using the optimizations that we had. And let's wait for it to finish. And hopefully, it should work this time. I'm actually more surprised that we managed to get 5 stages building with optimizations on in the toolchain. Like that's an achievement of on its own. So yeah, we have the final package, the one that's refusing to build or to link. If I were more precise, it was a linker error related to relocations and probably PIC or PIE. Let's check the log file for libgcc. This is the shared version. I mean, nothing looks out of the ordinary. Looks so anytime now, hopefully it taking this long could be a sign of it building successfully, so I still don't know if it'll build or not. Either way, like it's good to see it work and all, but like we've regressed by 30 minutes, which is awful. So we need to fix that as well. Hopefully it won't be that hard. Yes, and there you have it. Finally took around 15 to 45 minutes to build. And let's check the log files. Yep, everything looks as expected. Let's do a find error, and the errors are as expected, so nothing out of the ordinary. Everything looks perfectly valid. Let's go back to the binaries and let's see if we have any weird errors or something. Okay, so there you have it. Took a long time, but it finally worked. I hope you enjoyed this. I'm going to spend some time working on improving this, behind the scenes. And hopefully we'll start working on the cross-compiled system in the following development log. Thanks for watching.